Okay, new notes about relative dating. The crust on the Earth is constantly changing due to natural forces, such as tectonic forces and weathering. A primary role of geologists is to use data found in rocks to reconstruct the relative dates of geological events that shaped an area. This term, relative dates, this means the order that things happened, not exactly how long ago. So in this chapter, we're not going to say that something formed 100,000 years ago or 7 million years ago. We're just simply going to say this happened first, and then sometime later this happened, and then this happened. Just the order. If we say this rock layer is 3,000 years old, or this layer is made by a volcano in the year 1000 BC, that is stating the absolute age. And we're going to be looking at that in coming chapters, but not now, not this chapter. If we say this rock layer is older than that one, or this rock layer formed first, then we are stating the relative age. Basic ideas that we need to understand are 6 different ideas, and we're going to talk about each one of these in turn. The principle of uniformitarianism, that's a big word for you. This is the idea that current processes are the same as they were in the past. However, their rates may vary. For examples, volcanoes have always been active on Earth. However, some years there are lots of eruptions and some years there may be no eruptions. This idea, the principle of uniformitarianism, is an assumption. We assume that erosion happens today just as it has throughout all of history. We assume that magma flows as it does today, as it has for all of history, but it cannot be proven. It may not be true. This is not an unreasonable assumption, this principle of uniformitarianism, but some people may disagree with it. The principle of original horizontality. This is the idea that rock layers are deposited horizontally initially. Any tilting or wiggly erosion at the top of a layer happened after the depositing. Layers are often called stratum for singular, one stratum here, one stratum there, there's a stratum over there. Or if we're talking about plural, lots of strata are piled up here, we say strata, not stratum. Bedding plane is the border between these layers or between these strata. These bedding planes may show erosion or contact metamorphism. Erosion is the wearing away because of wind or rain or rivers, whatever, ocean currents. Contact metamorphism, that is the changing of rocks because of heat and pressure. Okay, some bedding planes are nice and straight. This probably means that one type of rock was made directly on top of another layer. If there is a boundary between rock layers that's not uniform, meaning it's not straight and level, all wiggly, wobbly, and whatnot, then something like erosion or faulting probably occurred in the past. And this is known as unconformities. And there's lots of different versions of unconformities, each with their own special name. Examples of erosion include water currents, whether it be from rivers or from oceans, and erosion from wind. Here's a video that we'll watch right here. Let me stop for a moment and screen share again, but with better computer sound. Okay, apparently there was no sound to that video. Law of superposition. The closer a horizontal stratum is to the surface, the younger it is. So in other words, the deeper the layer, the older it is. Letter D, the law of continuity says matching rock layers on opposite sides of a feature are the same age. So if I was to draw this, I'd have originally, let's get in black here. Originally, I'd have a black layer, and then another layer, and then another layer, and one more here. And then we had river flow through this. And so that's going to be, first you erode that, and then you erode a little bit deeper, and then you erode deeper and deeper yet. And so now we can see that the picture I have on the left is sort of like the picture on the right with slightly different colors. But you can see then that the layers on opposite sides of a valley were originally all together. It's just that the river cut through it and separated the cliff faces. Law of cross-cutting relationships. A fault or an intrusion is younger than the rock layers that it crosses. A fault is a break, a crack. An intrusion is a thin layer of lava, a thin pipe of lava. Here we can see a picture where we originally had this gray material on the sides, this material here and over here. That gray rock was originally there. And then we had, let's get a little bit thicker here. Then we had this white layer here flow up through that gray layer. And then we had this black layer go through that. So this black stream of lava coming up is an intrusion. Law of inclusions. If a rock fragment is found in a sedimentary layer, the fragment is older than the sedimentary layer. You can liken this to a chocolate chip cookie, with the chocolate chips being pebbles or rock fragments. When you make a cookie, you have to first go out to the store and buy your chocolate chips. The chocolate chips were made in a factory weeks before they came to the store. And let's say they were made on October 1st. And then they went to the store and they sat on the shelf a little bit. And then on Halloween, October 31st, you pull out your bag of chocolate chips and you make yourself a cookie. So on the next day, November 1st, the cookie is 1 day old. But the chips, the little inclusions, those are like a month old. The little tiny pebbles in this rock then, in the same way, are older than the whole rock altogether. Okay, and that's the end of the notes. We are going to go over these diagrams after this.